On 4.6, question 7, looks like we're dealing with a chord, correct? Here's one chord with its two segments, and then here's the other chord. And well, it looks like it only gives us one value, 5. We know by this little indicator, that little tick mark, that this must also be 5. So again, the chord power theorem tells us that the segment of one chord times the other segment of that same chord, so 4x times x, is equal to 5 times 5. One segment of the other chord times the other segment of that given chord. So we evaluate 4x times x is 4x squared equals 25. You'll notice that there's not a single x value, there's just an x squared value, so we don't have to move everything to one side. I'll show you what that would look like and how that doesn't really help us. So you only have two terms here. We usually have an x term in there, something like this. Something like that, right? 1, 2, 3. This would be like our a, our b, and our c. So when you see that it's just x squared, you can actually solve from here, right? You can divide both sides by 4, because we want x by itself. So divide both sides by 4, you end up with x squared equals 25/4, and we want to undo that square. So what we'll do is take the square root of both sides. Therefore, we get x by itself, because the square root undoes the square, and the square root of 25 over 4 is equivalent to the square root of 25 divided by the square root of 4. And I know you guys know how to evaluate that. 5/4. This should be plus or minus, but you'll notice that if we plugged in a negative value for x, that it wouldn't make sense. So we'll just keep it at 5/4. Let's see. Alright, right here, number 10, we have a tangent secant. You see, this is the tangent, 3. And then we have the secant segment. So we'll use the tangent secant power theorem. Again, what that states is we take the tangent and square it, and that would be equal to, let's start with the external part of the secant. So this part right here, x times the entire secant, which is x plus 8. We get 9 from 3 squared, and then we get x squared plus 8x. You see here we have an x squared value and just an x value. So we should move everything to one side. Subtract 9 from both sides, and you end up with 0 is equal to x squared plus 8x minus 9. Here our leading coefficient is 1. So if we multiply the leading coefficient by the constant, we would get a product of negative 9. And then our sum should be 8. So what two numbers multiply together to get negative 9? Yet when you add them together, you get positive 8. Well, 9 times negative 1 equals negative 9, right? But if you add these two, you get 8. So let's split this middle term into those two values. 0 is equal to x squared plus 9x minus 1x minus 9. You'll notice after doing the box, since our leading coefficient was 1, you basically just take these two values, and those are going to be what end up right here and right here. Kind of play that out. X squared, 9x, negative x, and then 9. Or negative 9, right? That's a negative 9. Cool. So that makes sense, right? x times x is x squared. Negative 1 times x equals negative x. Negative 1 times 9 equals negative 9. As well as x times x equals x squared. And x times 9 equals 9x. So that works out. Here's our factored form, x plus 9, x minus 1 equals 0. So our solution should be x equals negative 9. So if you plug this in here, it makes it 0, making that whole side of the equation 0, making it a true statement. And then also x equals positive 1. Same idea here. If you plug in positive 1, you get a 0 for that binomial. Multiply anything by 0, you get 0. Okay. So, are both of these realistic answers? Well, x, if you look right here, is a distance, and distance is not negative. So this one we can disregard. In this case, x equals 1 would be our solution. Alright, let's try this one. This one looks a little tough. So, I should probably get rid of all this. Okay. Computer's slow. Looks like we have two different things going on. We can look at this as a tangent segment and a secant segment. So I'll set that equation up first since I just drew these out. We know that 18 squared is equal to x, so that's the external part of this green secant, times the entire secant, which is x plus 12 plus y. Alright, now we'll FOIL that out in a second, or distribute it out in a second, but I want to also bring your attention to the two chords that are here. Here's this chord with two segments, 12 and y, and then here also is this chord with two segments, 4 and 9. So we can set up this equation. 12 times y, maybe I'll do them colors, that'll help. 12 times y is equal to 4 times 9. Okay, so this will actually give us the value of y since it's just one variable in this equation. And then we can plug it in up here. So 4 times 9 is 36. 36 equals 12y. If we divide both sides by 12, we get that y equals 3. So if y equals 3, can we just plug it in up here and find out the solution for x? Well, let's try it out. 18 squared, we said is 324. And then we have x times x plus 12 plus, and y equals 3, right? So we'll plug in 3 for y. 12 plus 3 is 15, so I'm just going to take this, erase it, and put in plus 15 so that we can save some space. 324 is equal to x times x, that's x squared, plus 15x. So one of these situations where we should say x squared plus 15x minus 324 is equal to 0. Alright, now if I did this right, we'll have to find two values with the product of negative 324, yet their sum equals 15. So this is how I always do this. I'll keep the negative for the very end. But essentially, we're going to break this down. We know that 2 times 150 plus another 12, that's 162 times 2 equals 324. We can break this down into 2's as well. That would be 81. 81 times 2, correct. And then 81 breaks down to 9 times 9, which breaks down to 3 times 3 and 3 times 3. So this is called prime factorization. We have 2 times 2 times 3 times 3 times 3 times 3. So we have to choose some of these numbers to multiply together. Let's say 2 times 3 times 3. That's 6 times 3. That gives us 18, which in this case, we'd also have to multiply these together. 2 times 3 times 3, that's also 18. But 18 and 18, which does equal 324, when you sum them together, doesn't give us 15. So maybe we'll try, I think there's an easier way to do this, but I'm going to try this. We get 9 from those two middle terms, and then the outside terms would be 2 times 3, which is 6, and then also 2 times 3 again, which is 6. So 36. In this case, we know 9 times 36 equals 324. Now if we took 36 and added negative 9, we would end up with 27. Oh man, that's not the number we want. Let's see. Perhaps we can do 2 times 2 times 3. That's 4 times 3, that's 12. And this is 3 times 3 times 3, that's 27. So, you'll see this gives us 12, 2 times 2 times 3, and then 3 to the power of 3, or 3 times 3 times 3 gives us 27. So this equals 324. Ah, here we go. 27 times negative 12. Remember I said we're going to save the negative for the end, so I don't have to confuse ourselves. Equals negative 324, but when you add them, plus negative 12 equals positive 15. So 27 and negative 12, those are our values. 27 times negative 12 equals 324. 27 plus negative 12 equals 15. So that we can use the box, splitting this term into 27x and negative 12x. But at the end of the day, since the leading coefficient here is 1, I know that it's just going to be these two numbers that go right here, 27, and right here, negative 12. So x squared, this one would be 27x, this one would be negative 12x, and this one would be negative 324. Yeah, if you do all that, you'll see that x plus 27 times x minus 12 equals 0 is the factored form of this here. In which case, we should know our solutions are negative 27 and positive 12. Now, will negative 27 work for this problem? No. This can't be negative 27. It has to be a positive value. So we know that x equals 12 is the correct one.